Find the derivative of f of x equals the secant of the square root of x squared plus 1. F of x here is made up of a trig function, the secant of an entire expression, the square root of x squared plus 1. Since we have a radical, we may want to rewrite that as a fractional exponent for the derivative. X squared plus 1, all of that is raised to the first power, but then second root, or 1/2 power. The secant is not inside of that 1/2 power, and therefore the secant is the outermost function. The 1/2 power affects only x squared plus 1. Our derivative, f prime of x, will start with the outermost function, that is the secant. The derivative of secant is secant times tangent. Now you leave the inside alone. I'm going to write the first version of the inside. That's that square root of x squared plus 1. We have the secant and the tangent of that for the derivative of secant. Leave the inside alone. But because the inside isn't just an x, but rather an entire expression, we have to multiply by the derivative of the inside. That's where the second version up here comes in handy, the derivative of the inside. So we have to take the derivative of that. Well, that is a expression raised to the 1/2 power. The 1/2 power is the outermost, so we'll start with the power rule, bring the 1/2 down, leave the inside alone, subtract 1 from the power. I will call that 2/2. And now we need to multiply by the derivative of the inside of that, because that inside isn't just an x, but rather an entire expression. The derivative of x squared plus 1 will be 2x plus 0, or just 2x. It's a double chain rule. We have an x squared plus 1 inside of a 1/2 power and then inside of a secant. That requires a double chain rule. The next step is to rewrite this. So I will have the first part of it, I'm not going to change at all. So the secant and tangent of the square root of x squared plus 1 will leave the way it is. But here we have a 1/2. I can move the 2x to the front. Everything's multiplied here. And the reason I would do that is that 1/2, that 2 in the denominator and that 2 in the numerator from the 2x can cancel. Everything's multiplied, so those can cancel with each other. And then also I have an x squared plus 1, and it will be to the 1 minus 2, which is negative 1/2 power. That means I can move it to the denominator. Only that quantity is a negative 1/2 moves to the denominator. Everything else stays in the numerator. Left in the numerator, I'm going to have a 1, and I'm going to have an x. 1 times x is just x. I'm going to put that first. Everything's multiplied in the numerator. So I'm going to have an x, a secant of the square root of x squared plus 1, the tangent of the square root of x squared plus 1, and then all of this over, moving the negative exponent to the denominator, x squared plus 1 to the positive 1/2. Of course, positive 1/2 means first power and second root or square root, so we can rewrite one more step. X secant of the square root of x squared plus 1, tangent of the square root of x squared plus 1, the entire thing divided by rewriting 1/2 power as square root, also of x squared plus 1. Now, looking at this, there might be a temptation to cancel because you see a square root in the numerator, but it's stuck inside of a trig function secant or inside of a trig function tangent, and you can't change those at all, so there's no cancellation possible here. This is the simplified version. There's our derivative, f prime of x.